Okay, we have another one that we're going to do. We're going to do it two different ways. First using the Hopitals and then using traditional methods. You're going to find in this problem that it's going to be a lot easier to do the problem with the Hopitals rule. So let's jump into it. First, you want to make sure that it is something that you can apply the Hopitals to. You put 0 into here. Cosine of 0 is 1, so 1 minus 1 is 0, and you get a 0 on the bottom, so therefore you are able to use the Hopitals. Let's apply that. So we're starting with that one, and then what you're going to do is keep taking the derivative of the top and bottom. For this one, we have derivative of cosine is negative sine, but because you have a negative out front, that means that'll just turn into positive sine x. On the bottom, we do a derivative, and we get 8x. Now if I put 0 in the top and 0 in the bottom again, sine of 0 is 0 and 8 times 0 is 0. So again, I have to apply the Hopitals one more time. So now I'm going to take the derivative of top and bottom one more time. Derivative of sine is cosine, so I get cosine of x. Derivative of 8x is 8. So now let's put in 0. If I put a 0 in here, I get a 1, and I have 8 in the bottom. Therefore, I know that I need to stop. I don't need to take derivatives anymore, because when I put the 0 in, I'm no longer getting that 0 over 0 situation. So your answer is going to be 1/8. Now, let's do it by using traditional methods, and this is going to be a little bit more complicated. Okay, so what we're going to do first when we start with this is we're going to take the conjugate, we're going to multiply top and bottom by a conjugate. Okay, so there's not really any way algebraically we can work with that unless we do this step. So I'm going to take the conjugate, just do top and bottom separately here. And again, this is using traditional methods that we studied before in a previous chapter. Okay, so then we get limit as x goes to 0 of 1 minus cosine squared over 4x squared, and I'll leave all this as is. I'm not going to multiply this out. And then what we can do with the 1 minus cosine squared is we can use a trig identity and make it sine squared. The reason why we're following this path, by the way, is because we're trying to get those special trig limits that we talked about before. Sine x over x is going to be 1. That's ideally what we're doing here, and that's why we're changing it over into a sine squared. The rest of it is still the same on the bottom, so I'm still keeping that exactly the same. Now, this is the part where it gets a little bit more confusing here, is because you may not know exactly how to break that up. What you want to do is you want to think about which way I can break this up to get special limits. So I need to rearrange this. Okay, so I'm going to do limit x goes to 0. And then here's how I'm going to write this. I'm going to do sine x times sine x, because that's the same thing as sine squared. Now on the bottom I have a 4x squared, so I'm going to put one of the x's here. I'm going to put another one of the x's there. Okay. Again, I'm doing that, breaking this up purposely. And then what do I have left over? Well, I have a 1 left over, and then I have a 4 down below times 1 plus cosine x. Okay. So that's basically what I have. If I multiply the whole entire top, the whole entire bottom, I'll get exactly the same thing as what I have here. So this is the hardest part, is knowing how to break that up. But again, nothing changed, and that didn't change the problem. It still simplifies back to the same thing. Now that I have this complete, I can start putting in zeros. Okay, now we know that this and this, those are special limits. So I'm going to get 1 times 1. And then this one over here, I can just put in 1 plus cosine of 0. And then what happens here is cosine of 0 is 1, so I get 1 plus 1 here is 2 times 4. We get exactly the same answer. We get 1/8. So again, it confirms that L'Hopitals can be used to get exactly the same answer. But notice in this problem it was a lot easier to use L'Hopitals than using traditional methods.